So let's talk about another way that we can perform, another operation that we can perform with two functions, and that's called composition of functions. And when we have composition of functions, we write them in such a way where we have your two functions. Your first one is when you take your second function and you plug it into your first function and follow those operation rules. And the second one is when you take your first function and you plug it into your second function. We'll talk about that in just a minute. When you have something that looks like this, you can write it as, in this case, f of g of x. And this guy over here would be called g of f of x, basically. And you're basically just taking your previous function and you're plugging it into your other one. So we're going to do this first one, this first composition first. So f of g of x, you're basically taking g of x and you're plugging it into the parentheses. So you're keeping your f on the outside and you're plugging in your g of x into the parentheses. So 5x plus 3. Okay, so now we have this guy. What that means is wherever you have your f function, you are plugging in 5x plus 3 wherever you see x. So anywhere you see x, this whole function, 5x plus 3, gets put into that new function, or that original function of f. So our original function of f is 2x, so 2, and then x would go right here, but instead of plugging in x, we're going to plug this whole g function into that spot. Once you do that, you can carry this out, all the operations, and distribute, add, subtract, and do whatever you need to do with your order of operations. If you carry this out, 2 times 5x gives me 10x, plus 2 times 3 gives me 6. So f of g of x in this case is 10x plus 6. If we look at g of f of x, I'm now taking this entire f of x and I'm plugging in 2x now. And when I do that, I get g still on the outside. I'm plugging in 2x, and that means wherever, because g is the last function on the outside, I'm going to take my skeletal g function, and wherever I see x, I'm plugging in 2x. So since g of x is 5 times x plus 3, that's my original g, wherever I see my x, I'm plugging in 2x, and then I just carry out my order of operations according to the problem. So in this case, 5 times 2x only gives me 10x plus 3. The 3 is on the outside, so I don't add, I don't distribute the 5 to it. And the one thing I really want to point out and note here is that f of g of x is not equal to g of f of x. Even though they may look alike, you know, the values on the outside, if f starts or g starts, it doesn't really matter, but they're not equal. As you can see here, the 10x plus 6 and the 10x plus 3, they're not equal. Therefore, when you have these two problems, it's really important to make sure that you know which one you're starting with on the outside and which one you're plugging in on the inside, so that you don't flip-flop them, because they are not the same thing. Alright, so in the next example, example 3, we're going to talk about letter E, F, and G, and then move on to example 4, and then there's a couple problems at the end of this packet that we're going to work on before the next time we meet. So let's look at the next video, which is talking about example 3.